Hello and welcome to Advanced Mathematics 1, Unit 9, Part 1, Graphing Absolute Value Functions. By the end of this lesson, you will be able to do the following. Graph the absolute value function and its translations. That means like shifting it up or down or left or right. Stretch, shrink, and reflect graphs of absolute value functions. I don't ever use the term shrink because it makes more sense to use the term stretch. So just so you don't think, well, she never talked about shrinks. One of them is, I just don't remember which one. So I'm just going to call them both stretches. And combined transformation of absolute value functions. In other words, it could have both a reflection, a stretch, and a translation, for example. All right, main concepts. First of all, the absolute function is f of x equals the absolute value of x, or y equals that. Its vertex is at 0, 0. Its domain is all real numbers. Its range is y is greater than or equal to 0, as long as the vertex is at 0, 0. But it moves around depending on the problem. Basic graph and its transformation. So this is going to show you what all the graphs look like and how they affect things. So the base graph is the absolute value, y equals the absolute value of x, or f of x equals that. And it just looks like a V starting at 0, 0 and going up at a 45-degree angle on both sides. A vertical shift is going to push that V up or down if that k is negative. A horizontal shift pushes it left or right, depending on the value of h. The other three are a vertical stretch, because it basically pushes it kind of in and up. So I call it a vertical stretch because it's kind of being elongated up and down. Horizontal stretch is being elongated left and right, so that's what I call it that. One of these is considered some sort of shrink. Don't know. That doesn't make sense to me. Nothing looks like it shrank, so I don't know. And then a reflection is basically just the basic graph turned upside down, and that's that. Let's go ahead and jump into our examples. So we are going to start with y of x equals the absolute value of x minus 4. So our first goal is to figure out what the vertex is. So I'm just going to abbreviate that b. There's nothing inside here with the x. That means the x value is 0. And the number on the outside of the absolute value is the y value of the vertex. So I'm going to start by finding 0, -4 on the graph, and I'm going to put my dot. And this is a V, like I said, going at a 45-degree angle. In other words, a slope of 1 and -1. There are always mirror images on both sides of the axis. So I'm going to try my best to do this straight. I'm very bad at straight lines with a mouse. So you get the idea, going that way, and then the same thing going the other way. The idea is that the left and the right side are identical, they're just going opposite directions. All right, in example 2, we have y equals the absolute value of x plus 1. So again, we want to start by finding our vertex. So what the x value is the value that makes the inside of the absolute value 0. So -1 would be with the x value that would make that 0. And there's nothing on the outside of the absolute value out here, so that means it's 0. So my vertex is at -1, 0. And then again, I just draw my B. So 45-degree angle, at least for these basic ones where there's no stretches going on or anything like that. So there's a stretch. I'm going to show you how to deal with those in a bit. You can excuse it to be not perfectly right, but that's what it looks like, and that's all for that one. All right, in example 3, we have y equals -5, absolute value of x. That means there's a number in front of the absolute value, which is going to cause a stretch of some sort. It's also a negative, so that's going to cause this thing to be a reflection. So it's going to go down instead of up. What we will find our vertex first, as we always do. The vertex is going to be the number that would make the inside of the absolute value 0, which is 0, and then the number that's on the outside of the absolute value, which there is none, so it is at 0, 0. So I can just go ahead and put that down. Now, to find the other points, you're going to start with what happens with the base graph. So if this was just the absolute value of x. So if I had the absolute value of 1, I would have y equals 1. But this is not just y. It has this -5 out front. So what I'm going to do is I'm going to multiply the y value by that number to get another point. So 1 times -5 is -5. If I wanted to go a second one, I could go 2, and then the absolute value of 2 is 2, and then -5 times that would be -10. So the points that I would want to do are go 1 away left and right on the x, and then -5 away on y, on the y. So I go over 1 on x and down 5 on y. And then the same thing on the other side. You'd go the other way, 1 and down 5. So it's going to be the mirror image. And then 2 would be down here at 10 and 10. So it's 2 away from the axis, and then 5 more down from the previous point. Oh, this is I'm going to erase that, sorry. Very bad graph, very bad. Let's try this again. I'm really bad at drawing lines. Oh my gosh. I cannot draw today. Sorry. Draw straight, draw straight, draw straight. All right, let's try one more time. Third time's the charm, right? All right. I can't draw straight. Okay. Connect the dots, basically. As best as you can. Probably better than me, I can tell you that. So let's move on. All right, in example 4, we've got a lot going on. Let's just start like we normally start, which is finding the vertex. So the value that makes the absolute value 0 is -3, and the value outside sitting out on the back side here is +2. So my vertex is -3, +2. So up here. Now I'm going to do what I did last time. I'm going to do the normal graph, except this time I'm not going to use 1 because I don't want to multiply that by -4/3. The final thing that I'm going to do is multiply by 4/3 this y. So when x is 3, I will start with 3 because that's a multiple of, that'll get rid of the denominator. For the absolute value of x, it would be 3. And then I multiply that by -4/3, and the 3's cancel each other, and I'm just left with -4. So that means for every left and right 3, I go down 4. So you can just use that pattern from each consecutive dot. It's a lot easier than plotting 2. So I'm going to go 3 this way to the right, and then I'm going to go 4 down from this vertex. So 1, 2, 3, 4, and get another point. And then I'm just going to go across the line. It's easier. Here's the vertex, and I'm going to go 3 the other direction. 1, 2, 3, and there's my next point. Now if I do that again, from those points, I go 3 on x and 4 down on y. 1, 2, 3, 4. That will give me another point on the graph. So let's do the same thing. We're going to go across and then go 3 more on the x value, back the other way. And then we have our nice little mirror image graph like that. And there we go. All right, in our final example, we've got something going on here. There's something in front of the x inside the absolute value. When it's like that, you need to change your graph. First, I'm going to call it y because it's easier. What you're going to want to do is you're going to want to factor out whatever is in front of the x from the expression inside the absolute value. So I'm going to take a -4 out and divide everything by -4. So -4 times x, and then plus 2 divided by -4 is -1/2. And then I still have that plus 2 on the outside. All right, so now that you have a multiplier, you can separate the two parts, the -4 and this, into two separate absolute values. So you can go y equals the absolute value of -4 times the absolute value of x plus -1/2, or just -1/2, whichever way you want to write that. And then we have the plus 2 still on the outside. And now we're almost done. We just got to figure out the absolute value of -4, which is just 4. And then we have x minus 1/2 plus 2 on the outside. All right, after you've done that, now you're ready to find the vertex like we normally do. So my vertex is going to be what makes the absolute value, which I can't seem to write an absolute value sign on both sides for some reason, of x minus 1/2. Sorry, my bad. Erase that for a sec. I still have that 4 out front. Got to write that first. So 4, I don't need to write that. I'm doing the vertex. My brain is not working right this morning. I'm sorry. So the value that makes the inside of the absolute value 0 is 1/2. And then the value sitting on the outside of the absolute value is 2. So my vertex is at 1/2, 2. So 1/2, 2 is like in the middle here. You know, you can't be totally precise there, but there it is. And we're going to do our same little xy thing, except this time on the outside is a 4. So this will be 4y on here. So again, when x is 1, the absolute value of 1 is 1, and 4 times 1 is 4. So for every change in x that is 1, we will move 4 up in y, because it's not got a negative out there. So 1 value over and 4 values up, 2, 3, 4 is here. Same thing over here, 1 value over, 4 values up. So very, very skinny. This is a vertical stretch. And let's see, could I go another 1 and another 4? I can. So I'll go 1 more over, 4 more up, and 1 more over, 4 more up. Just the more dots you have, the easier it is to draw the graph. It's not necessarily necessary if you've got a ruler and you want to try and do it that way. It just comes out way better if you have multiple points to draw through. And that's all for this lesson, and I will see you next time. Goodbye.